So let's start today's class. Okay, just give me a couple of minutes. Okay, I'm just starting. Okay, just give me a couple of minutes. Yeah, we want to ask something? Okay. Nice. So from today, we are going to start with the dynamic routing. Okay. So everyone, please confirm. Can you see my screen or not?
Yes, sir.
Okay. That's it. So okay. So the thing is, there are a lot of advantages and disadvantages regarding this thing. Okay. Yeah, you want to ask something? You can ask right now to me. You message me, yes, sir. Tell me what you want to ask. Okay, okay, okay. No issues. Okay. Yes. Now see. Okay. So there are various advantages and disadvantages for static routing. Okay. However, the disadvantages are more compared to the advantages, such as I'll just write down. Okay. So now, so so if I have to compare static routing in terms of advantages and disadvantages. Right. Okay. So the advantage is that it is more secure. It is more secure than dynamic routing. And the second thing is it cannot waste the band. However, the disadvantages are more, such as while entering while introducing a route, okay, into the routing table of any router, we must know destination network information. Must know destination network information. First thing. And the second thing is that it is not scalable in large, medium, and large scale industries. It is not scalable in medium and large scale enterprises. Okay, where where are hundred of routers are working, and you have to identify that which one is the next hop IP address to introduce a particular network into a router. Okay, that's not easy task. So that's why this is another it's a disadvantage in this, and it is very difficult to troubleshoot. Very difficult to troubleshoot. Okay. So there are various disadvantages. Okay. The biggest disadvantages, if I would say, so they are these two. That you must know destination network information, and it is not good for medium and large scale enterprises. Yeah, you can use this particular routing, and it is good for small scale industries. Let's suppose where are only 5 to 7 routers are there, and you can easily know the destination. You can easily know the destination network information, and as well as the next hop IP address. But in case of medium and large scale enterprises where hundred and thousand of routers are working, it's not viable and it's not very easy to get to the information of which one is your next hop IP address. So you have to figure it out some things. So in order to working on these disadvantages, we come to know, we discovered different type of routing, which is known as my dynamic routing. Okay, and we divide dynamic routing into broadly two parts: IGP and EGP. Whereas IGP stands for Interior Gateway Protocol and EGP stands for Exterior Gateway Protocol, like this. Okay. Oh, sorry. Is it fine for every one of you sitting here? Tell me.
Yeah.
Yeah, yes, sir.
Okay. Now, so under IGP, we have four protocols such as RIP, EIGRP, OSPF, and IS. And under EGP, we only have a one protocol, which is known as your BGP. And we divide BGP into two parts. One is IBGP and another one is EBGP. Like this. Like this, we divide into two parts. Clear? Any doubts on this? So
No.
from today, we're gonna start with RIP, this protocol. Okay, we will thoroughly discuss this theory of this protocol in today's class. Okay, so try to understand. The protocol which we're gonna use is RIP. First of all, what does RIP means? RIP, it stands for routing information protocol. Okay, this is the full form of RIP. What? Routing information protocol. Clear? Now, let's write down some points regarding this. The first point is that it is an IGP protocol. It is an IGP protocol. It means it means it works within the organization. Means it works within the organization. Okay, now second point. It is an open standard protocol, which means it works in all company, or you could say vendor devices. This is the second. Third point is it is an layer 7 protocol. Fine. Okay. It is a distance vector routing. Okay. If anyone asks you in the interview, which protocol is known as your distance vector routing protocol, then you have to say it is RIP, which is routing information protocol. Next, point number 5. It uses port number UDP port number 520. Make sure this is the port number for just a second now. This is a port number for RIP. This is UDP port number 520 for RIP. Like this. Okay. The sixth one. Okay. It uses Bellman Ford algorithm for the selection of best path. Okay, now comes on to 7.1. It uses hope count as a metric. Next, point number 8. Its AD value. Its AD value is 120. Again, it is an important point. Its AD value is 120. And its hope count, it uses hope count as a metric like this. Now, let's move on to the point number 9. It sends an update packet every 30 seconds. Yes. 10 point. It works. No, it should not. You should not write it works. You should write it supports. It supports maximum to maximum. 16 routers. And its maximum metric is 15. Dead timer is equals to 180 seconds. And it uses multicast IP address 224.0.0.9. Third point is it has two versions. One is RIP version 1 and another one is RIP version 2. Okay. Yeah, everyone. These 13 points.
Yeah.
Okay. Now we have to go through these 13 points one by one. Okay. So let's start with the first point. What does first point says? Which type of protocol is RIP? It is an IGP protocol. So what does IGP stands for? So IGP stands for Interior Gateway Protocol. isn't it? That's what I told you. IGP stands for Interior Gateway Protocol. Clear? So it means it works within the organization. Now, what does this word mean? Means works within the organization. Now, just try to see here. What does it mean? Let's suppose you are sitting in an organization and this is a topology, something like that. Okay. Let's suppose like this. Okay. The way we did in the case of static routing. 10.2, 20.1, 20.2, 30.1, 30.2, sorry, 40.1, and 50. So let's suppose 30.2, 30.3, 40.2, 40.3, and 50.1, 50.2, and 50.3 like this. So now let's suppose I've enabled. So I want that these all networks, that network 30 should communicate with network 10, 40 should communicate with 20, and 50. So for this, I have to enable a routing. Okay, so routing has been enabled. And now these networks which are inside the organization have started communicating with each other. So it means now 30 is communicating with 40 and 40 is communicating with 50, 20, 10, same in the case of 30 as well. Okay, now let's suppose one of these user wants to use Google. So what does it mean? Now for that Google, I have to communicate with my ISP. Now this is my ISP. What my ISP has done, it has provided me a router like this. And on the one side, it is connected himself. And on the second side, I have connected myself like that. And we have an IP address working here, something like that. Let's suppose 200.1, 200.2, and same way here. They have configured themselves as well. Let's suppose, sorry, not 300.1. This is 100.1 and 100.2 like this. Now, so you see, earlier, the communication is within the organization. Okay, this organization is communicating with itself. Okay, but now it has to communicate with the outside the organization because my all the let's suppose my Google, YouTube, and every user, every online media platform has been connected with my ISP. So ISP connects each and everything, Instagram, your Facebook, each and everything, name them, and they all are connected with the ISPs. Whatever we are using on internet, they all are connected through a ISPs. Now, so now the communication has to go via ISP. So now you see, I can divide this thing broadly into two parts. One is inside the organization and another one is outside the organization. So outside the organization, if I have to communicate, then I have to configure my EGP protocol, Exterior Gateway Protocol, which is my BGP. And if I want to communicate internally inside the network, then I can do this work with the help of IGP protocol, either with RIP, EIGRP, and OSPF. Is it fine? What does this mean? It works within the organization. RIP is something which works within the organization so that inside the organization, different devices will be able to communicate with each other, or different networks will be able to communicate with each other. Is it fine till here or not?
Yeah.
Okay. Wait, what about you, Mini, Abdul, Anu?
Yes, I have a
Yeah, it's
question.
fine.
Yes,
So,
what is the difference between the gateway and the firewall?
sorry, repeat again.
what is the difference between the gateway and the firewall?
Well, we will discuss someday. Okay, just keep this question as a star. Just make a
Okay,
star on this question. Okay, because if I started discussion, then we will deviate from the topic.
no
Okay.
problem. Understand.
Okay.
Thank you.
Okay. So do one thing. In Monday on Monday. Okay, you could ask me when we'll start the
Okay.
when we start the topic, so you can take it out in the first 10 minutes. I am going to take it out in the first.
Okay.
See. So I hope this first point has been clear to each and every one of you. What happened? Now, next point says that this particular protocol, that RIP is an open standard protocol, which means it works in all the company or vendor devices. Now try to understand. Now, right now we are learning CCNA, isn't it? Okay, so now, and the devices which I'm using currently, they all belong to Cisco. Either I am going to use router or I'm going to use my switch. So they all belongs to my Cisco, the Cisco proprietary. The protocol, which is RIP, it can work in Cisco devices as well as other vendors such as Juniper, UI, Aruba, and etc. So this RIP protocol we can configure either on Cisco router or on Juniper router or on Huawei router or last is Aruba router. That means it is an open standard. If it is a proprietary protocol, let's suppose if it is a Cisco proprietary protocol, then that means that only RIP can be configured on Cisco devices. However, it is not like that. It is an open standard protocol. Clear, everyone?
Yeah, anyone can use, right?
Sorry? Any vendor.
Any vendor,
Exactly.
any vendor can use.
Exactly. And on any vendor device, I can configure RIP and it will work fine. Okay. And the next point is the RIP is my layer 7 protocol. Which one is a layer 7? Which layer is known as a layer 7?
Application.
Everyone forgets OSI model, isn't it? Now. So on this slide, you just have to memorize each and everything. Like, for example, on the second slide, the points which I've written here, it's a distance vector routing protocol. Okay, you just have to remember this because they could ask you in an interview that which protocol is known as the distance vector routing protocol. Then you have to give the name. And they could ask you which port number are they gonna use to send the traffic. So it would be, make sure it would be UDP 520 because there are two types of port. One is TCP and one is UDP. Okay, they could ask you, is it TCP 520 or is it UDP 520? So the answer is UDP 520. Make sure this. Yeah, now.
Hello, sir. It does not work on TCP.
No, RIP does not work on TCP. It works on UDP.
Okay.
UDP port number 520. Okay. Now, the next point is it uses an algorithm. So which algorithm has been used by RIP to calculate the best path? The name of the algorithm is Bellman-Ford algorithm. Again, another thing to be memorized. Okay, the protocol used by the algorithm used by RIP to calculate the best path is Bellman-Ford algorithm. They will not ask you how this Bellman-Ford algorithm works. Okay, that's not the question they're gonna ask in your interviews. And now, and this is also one of the point to remember, it's AD value. its AD value is 120. And I hope the full form of AD you all know. Administrative,
Distance.
exactly. Lower the AD value, the best path it is. Make sure this. Okay, so now this has been done. So now what I'm gonna do, I'm gonna take, okay, point number, yeah, okay, now what I'm gonna do, I'm gonna take this point number 9, 10, 11, all of those in a one go. And make sure you have to memorize these things as well, that uh RIP uses multicast IP address, which is my 224.0.0.9. They all are potential info. They are all are potential interview questions. So make sure this. Okay. And how many versions does IP has? It have two versions, are version 1 and version 2. Make sure this. Now, the thing is how RIP works. Now we have to understand how RIP works, and I'm gonna take all those points, the remaining points, such as it sends a packet every 30 seconds and supports maximum each and every point in a one go. Now try to understand. Let's suppose this is my router 1, which has been connected with router 2 like that. And in router 1, we have a switch connected to it, which is switch 1. And similarly on router 2, I have a switch which is connected to it. This is known as switch 2. And we have some end devices connected to both of the switches like that. Now, try to give the IPs 10.1, 10.2, 20.1, and 30.1 like this. Yeah. Now, so just tell me, by default, in R1's routing table, what all networks can we see?
10 and 20.
Exactly. 10 and
20.
20. Good. Network 10 and network 20. And by default on router 2 routing table, what are networks we can see?
10 and 30.
20, 30,
Exactly. 10 and 30.
30.
Exactly. Now the question is, what all our networks needs to be introduced in R1s and R2 routing table? What else networks we have to introduce?
For R1,
In R1 30
Yeah,
and in R2 20.
R2 20. Now the thing is, how these networks should be exchanged between them. There's a lot of noise coming from backside. Whose mic is on? Dude, I think your mic is. Just check once, please. Just try to see. Okay, now this is R1's routing table, and this one R2's routing table. What will happen? Let's suppose I have enabled RIP on both the routers, like this. So the moment I enables RIP on both the routers, what both the routers will do? They will generate an update packet. After enabling RIP, an update packet would be generated like this. And in this update packet, we have the routing table of router 1, router 1 routing table. Similarly, router 2 also generates an update packet. And in this update packet, what they will do, they will put R2's routing table. And after doing this, these routing table will be exchanged between the neighbors. Clear? Is it fine to each and everyone or not? Tell me.
yes, sir.
Okay, now what R2 will do? R2 will see R1's routing table and it will check what all are the new networks which I can learn from router 1. So it will see that in R1's routing table, the 10 network is already there, which I have learned. But a new network is coming, which is 20. So what it will do, it will insert this particular R2, oh sorry, in 20, network 20 in its routing table. It will write something like that 20 via your, it is coming via 10.1 because the command, the routing table looks like it has been introduced through a static route, but it should not be but it should not be introduced via static route. Okay, I will tell you when I will show you. Okay, don't worry. So via 10.1 and its AD value is 120/1. This one means this one stands for, just give me a second now. Yeah, this one is your hope count. And this 120 is my AD value, like this. Okay, now similarly, R2 has also exchanged an update packet with R1. R1 will also go through the update packet of R2 and see what all networks can I learn from it. So it will see a 10 network is coming from R2. It will say, okay, I have it, don't worry. And it will say a new network is coming, which is 30. So what it will do, it will learn this network, new network 30.0.0.2, which is coming via 10.2 with AD value as 120 and its hope count as 1. Clear, everyone?
Sir.
Yeah. Want to ask something?
No.
Anu, AK, Abdul,
Got
Daily,
it.
Got it, sir. Fine.
everyone got it? It's simple?
Yeah, yes, sir.
Okay, good. Just a second now. Yeah. Next comes now. Just write down. So all of you understand that how RIP exchange the information with each other. Tell me. And this packet has been exchanged after every 30 seconds. You can see I have written here. The update packet, it sends the update packet after every 30 seconds. So just tell me, is it a good practice or a wrong? Is it a bad practice? Tell me.
Bad practice
Why?
because it consumes lots of bandwidth.
Sorry, it consists of
It consumes lots of bandwidth.
bandwidth. You're saying bandwidth.
Yes, sir.
Okay. Anyone else?
It's a good practice, sir.
So who is saying good?
Yeah, we
Okay, Veer. Why good, Veer?
because there is a updates in every 30 seconds. So
Okay.
hello packets are being exchanged.
It's update packet, not hello packet. Clarifying you. Okay. It's an update packet, Veer. When we'll
Okay.
go to EIGRP and OSPF, there will be hello packets coming. That's
Okay.
why I didn't write update. Okay. That's
Okay.
why what I'm written is update packet. Under the update packets, routing tables has been exchanged. Clear?
Okay.
Don't say hello packet in RIP. You will be disqualified in an interview.
Okay. Got it.
Okay, now, okay. So I think AK is saying bad decision and Veer is saying good. Okay. So anyone else? What about others? Yes, Anu, what is your take on this? Abdul, Mini, tell me what you guys think. Is it a good practice or is it a bad practice to send update packet after every 30 seconds? Are you all in the class or not? Anu?
Yeah, yes, sir. I'm
Is
there.
it good practice or bad practice? Tell me.
I feel like it's bad.
It's bad, okay. So we
Yeah.
have Anu as well here. Abdul, what about you? Mini, what do you think?
And I
I'm not
think it's
sure.
good practice.
Okay, okay. Abdul also says it's a good practice. And Mini, what about you?
Actually, I'm not sure. I don't know.
Okay, so that's what a vote we've got. It's equal. Okay, so now I will tell you. Okay, now let's suppose those who are saying it's a good practice. Okay, now just try to understand. If after every 30 second, if after every 30 second, I tell you about the AD value of static routing, is it good practice? Tell me. Is one. Now, tell me, Veer and Abdul, is it a good thing to do that? After every 30 second, I tell you that AD value is uh, 1. Let's suppose I'm teaching the command for static routing is IP route and suddenly 30 seconds over. So I says, okay, the AD value of static routing is 1. Then I will say, okay, the network to be introduced is 30.0.0.0 255.0.0.0. 30 seconds again done. Okay, the AD value is 1. So tell me, is it a good practice or wrong practice now?
No, sir.
So don't you think that each and every time your memory has been burdened with this thing, AD value? The way our memory has been burdened, similarly, routers also have a RAM. Don't you think it will impact their performance?
Your network will be slow.
Exactly, the network will be slow. Okay, if these update packets would be exchanged after every 30 seconds, what will happen? The performance of network will be impacted. It will become slow. Got it? So those who are saying bad, the explanation is this. And those who are saying good, they are totally wrong, first of all. So Abdul and we totally wrong. Okay. And the explanation which was given by AK. AK was not up to the mark. Okay, I would say. Okay. So try to use these kind of words which I am using in the class. Okay. The router's performance will be impacted. The RAM of router will be burdened by this update packet. Clear? Tell me.
Yeah.
Okay.
Yeah, yes, sir.
Cool. Can we move forward?
Yes.
Yeah, sure, sir.
Okay, now. So now the next point is which we have to work on is that what does this hope count means? Okay, and what does it what does this hope count means and why I've written hope count? And how we are gonna identify the maximum number of router is 16 and how we'll be able to calculate this metric as 15. So the first thing is that RIP, it works on only 16 routers. Beyond 16 routers, it will not work. So make sure this and keep this thing in your mind. So let's make 16 routers first of all. Router 1, router 2, router 3, router 4, router 5, router 6, router 7, router 8, router 9, and router 10. Yes. Router 11, router 12, router 13, router 14, router 15, and router 16. Yeah. I said that RIP supports maximum of 16 routers. So let's suppose there is a network connected here, which is 10.0.0.0, and it has to be introduced all the way till the 16 router. Okay, now it means that it has to be introduced in router 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And all of those routers, this network needs to be introduced. First of all, try to understand the meaning of metric. The meaning of the metric is distance. That how much distance 10 will take to reach to R2. And that distance is defined by as my hop counts. Clear? Now, try to see. This 10 network has to be introduced in router 2. So how many hop? Hop means devices. So how many routers are coming in their way? Tell me. How many routers can you see are coming in between 10 to reach to the 2?
2 routers, 1 and 2.
Only one router. It is passing by only one router, which is router 1, and introducing in router 2. When it will pass through router 2 to router 3, so now you will say that it is following by 2 routers, router 1 and router 2, like this. Then the hop count would become my 2. And similarly, if it goes to router 4, then the hop count will become 3. Similarly, if it goes to 5, then the hop count would be 4. And if it is come to 6, the hop count would be 5. Goes till 7, the hop count would be 6. If it goes till 8, then the hop count would be 7. Like this, we're gonna calculate our hop counts. So when it will reach to the 10, the hop count would be 9. If it reached to the router 11, then the hop count would be my 10, 11, 12, 13, 14, and 15, like this. This is the maximum metric. These 1, 2, 3 are hop counts and can be defined as a metric as well. So the maximum metric is my 15. Clear, everyone?
Yes, sir.
Yes.
Everyone understood or not? Tell me.
Yeah.
Yeah, understood, sir.
Sure. So just see all those points. If you want to ask me any points from the above, just let me know. So these are the first 3 points. You want to ask any of the point? Having any doubt in these points, in these first 3 points? Okay, so can I proceed further?
Yeah.
Okay.
Yes, sir.
So just go through all those points. Yeah. Is it fine till here?
Yeah, yeah.
Yeah, yes,
Now-
sir. It's fine.
Yes.
This one is the last. Okay, now this is your homework. I'm giving you the homework that you have to find the difference between RIP version 1 and RIP version 2.
Actually, I
Okay.
have a question. So
Yeah,
the
please.
RIP,
Yeah,
the RIP is going to be used only in small companies, right? Because it's only
exactly.
16 routers.
Very good. Exactly, you're right.
Okay.
These small enterprises. Make sure this. Okay. Now, this is I'm going to have the homework that you have to find the difference between RIP version 1 and RIP version 2. It's very simple, okay? So just you have 2 days of holidays and just one question. Hardly it's gonna take your 5 minutes. Hardly, I would say. Okay. So shall we wind up this class here?
Yeah.
Yeah, yes, sir.
Okay. So I hope everyone thinks clear and make sure you all do the static routing. You should also go through static routing once. If you feel any doubt, you're not getting the things right, just let me know. Okay. I will try to help you. Do my
Okay,
best.
sir.
Okay.
Okay.
And listen, in this class, those who are comfortable in Hindi can ask me in Hindi as well. Okay, I'm gonna explain you in Hindi as well. Okay, don't hesitate in asking Hindi. Anyone?
Okay, sir.
Okay.
Yeah, yeah.
Okay. So let's meet on Monday. Till then, good night. Bye bye. Have a good weekend, all of you.
Yeah, yeah. Thank you.
Yeah.
Thank you.
Thank you, sir. Good job.
Bye bye.